Good morning, my dear students. Shall we go to the next session of electrochemistry? So, before going into the next session, let us see the objectives of today's lesson. So, after completing this lesson or in this period, you will be knowing the EMF, that is electromotive force. What is EMF? How to calculate the EMF of a given cell? What is hydrogen electrode? What is the significance of EMF? And also about lead storage cell or lead storage battery. How it works? What are the reactions that takes place during charging? What are the reaction that takes place while discharging? That's all we study in this session. Are able to follow? So before starting, let us recapitulate what you have read in the last sessions, in previous sessions. So you know that we are studying the electrochemistry, and one more thing is that is electrochemistry is a study of relationship between electricity and chemistry, or study of processes involving the conversion of electrical energy to chemical energy or chemical energy to electrical energy. And according to electrochemistry, and that is under the study of electrochemistry, we classify the substances as conductors and insulators. Conductors are those substances which conduct electricity or which allow the passage of electricity through it. And conductors are two types: metallic conductors and electrolytic conductors. We are dealing with electrolytic conductors. Electrolytic conductors are the substances which allow the electricity and also simultaneously undergo decomposition, which we are also calling as electrolytes. And that process called as electrolysis. That is, in electrolysis process, what happens? The conversion of electrical energy to chemical energy takes place. And we have seen the Faraday's laws of electrolysis. We have done so many problems about that. Next, we have studied even the galvanic cell. What is a galvanic cell? If the electrolytic cell is the device which converts electrical energy to chemical energy, galvanic cell is a device which converts chemical energy to electrical energy. That means it produces electricity. So galvanic cell is a device which gives electricity. How it gives electricity? By chemical reactions. Are you able to follow? So we have seen the galvanic cell. What is a galvanic cell? Daniel cell, in which we have two electrodes, that is zinc electrode and copper electrode. The zinc electrode dipped in zinc sulfate solution in a beaker, it is taken as anode. And copper electrode dipped in copper sulfate solution in another beaker is taken as cathode. When the two are connected, when the two electrodes are connected, electrons flow from zinc electrode to copper electrode, due to which electricity is produced, is it not? So on what basis they are, that is, one is acting as anode, what is that? Depends upon their standard electrode potential. We have seen the standard electrode potentials and we have seen the electrochemical series. All these things we have studied. So based on their position in the electrochemical series or based on their standard electrode potential, an electrode acts as anode or cathode, is it not? So now that is, for a galvanic cell, there should be an anode and a cathode, and there should be a difference between the standard electrode potential. That difference is called as electromotive force. That's what we are going to study today. Are you able to follow? So what do you mean by electromotive force? Let us see the definition. The force with which electrons are pushed from anode to cathode in the galvanic cell, that is called as electromotive force. The force that causes the motion of electrons. Electromotive, that is, that makes electrons move from or pushing from anodic metal to cathodic metal. If you have seen the Daniel cell, zinc is giving electrons or pushing electrons. These electrons are traveling to copper. That is, copper is pulling the electrons. The force which pushes the electrons, or the force which pushes the electrons from anode to cathode, that force is called as electromotive. But what is that force? It is the difference between. So if you just pour the water on the ground, water flows to one side, a specific side. What does that mean? That is, water flows to a slope. Are you good? So it won't go to higher side, is it not? Similarly, that is always electromotive force. That is, electrons flow from lower electrode potential to higher electrode potential electrode. That is, there is an electrode potential difference due to that the force, there exists a force which pushes the electrons from an electrode of lower potential to the electrode of higher potential. That force is called as electromotive force. That is, simply in the case of Daniell cells, there is a force that is pushing electrons from zinc electrode to copper electrode. How to measure the standard electrode potentials? So this way. So you cannot measure a single electrode potential. So you cannot evaluate the ability of a person. Let us take yourself. How far you are getting good marks, or what is that? It is always evaluated in relation to the whole class, is it not? Similarly, the electrode potential, the strength of the electrode, that electrode potential means the strength, or what you call the ability to give or take electrons, that is measured with reference to some other electrode. It cannot be measured singly. It is always measured in relation to some electrode. That's why standard electrode potentials cannot be measured singly. So half electrode cannot make a circuit. If you take a single electrode, it cannot make a circuit. If it is connected with something, so whether it acts as anode, cathode, that depends upon the other electrode. So that's why half electrode cannot make circuit. So standard electrode potential is measured taking a standard electrode. What is that standard electrode? Hydrogen electrode. So it is not possible to construct a cell by single electrode. The absolute value of electrode potential cannot be determined. So that is, E cell is equal to reduction potential of cathode minus reduction potential of anode. I told you in the last class, the electrode potential you have to take sure only the reduction potential, not the oxidation potential. So the electrode potential of cathode minus electrode potential of anode means it is nothing but reduction potentials. Or Rp of cathode minus Rp of anode, or E cathode minus E anode, that is electrode potential of cathode minus electrode potential of anode, or E right hand side minus E left hand side. Generally in a cell notation, we write the cathode on the right hand side and anode on the left hand side. That's why it is not the placing of, because that you should remember. In cell notation, the anode is written on left hand side and cathode is written on right hand side. That's why E right hand side electrode, that is cathode, minus E left hand side electrode, that is anode. Are able to follow? So that is about the calculation of EMF. EMF of a cell. EMF of a cell is calculated from standard, and then it is indicated as E cell. A cell with positive value of EMF only generates electricity. If the difference between electrode potential is positive, then only it generates electricity. That you should remember. How to calculate the EMF of a galvanic cell? Let us take, this is the galvanic cell which we have studied, which we are calling it as Daniell cell. So are you able to see here? That is, zinc electrode is there, copper electrode is there. When they are connected through an external circuit, through a copper wire, and here an ammeter is also provided to show whether the current is flowing and how much current is flowing, that it shows, is it not? So what happens when they are connected? That is, here the zinc sulfate is taken with its own ions, that is zinc sulfate electrode. Copper electrode is taken with its own ions, that is copper sulfate electrode. And simply you just connect it with a wire. Electrons flow. The electron flow is from anode to cathode. But the current flow, the conventional current is flowing from cathode to anode. It is always opposite to electron flow. Are able to follow? And why salt bridge is there, that I told you in the last class itself. But simply when you connect two electrodes, there is an electron flow, there is electric flow of current. Are able to follow? Now, what is the cell notation here? That is, you know that always cell notation is written, anode is on left hand side and cathode is on right hand side. Anode is written with metal first, then electrolyte later, with concentration in brackets. Cathode is written on right hand side, first electrolyte, then metal. Both anode and cathode are separated by a double vertical line which indicates the salt bridge. The metal and electrolyte, they are separated by vertical line. Here the electrolyte and metal are separated by vertical line. So here they have even mentioned the concentration of the electrolytes, ZnSO4 or CuSO4. They are just represented in their ionic form. In ZnSO4 or CuSO4, the copper is 2 plus, Zn 2 plus, is it not? Okay, now so this is the what you call, this is Daniell cell and its electrode, what you call cell notation, or what you call representation of galvanic cell. Now we'll see. So what is the reaction at anode? Zinc plus 2 electrons. Zinc, sorry, this is not this reaction. This is actually, this is a reverse reaction. Actually, zinc loses electrons to give this one. So actually there the reaction takes place, but we have to take the reduction reaction only. So actually the oxidation takes place there. Actually, in this case, zinc loses electrons to give Zn2 plus ions. Actually the reaction takes place this way, but that is oxidation. We have to take in reverse way, that is minus 0.0. And here this reaction takes place as it is. Cu2 plus 2 electrons gives Cu. What is its electrode potential? That is, in both the cases you have to take the reduction potential. Here the reaction doesn't take place like this in reverse case, but why we have written like this? We have to take only reduction potential. In oxidation potential is 0.76. Its reduction potential is minus 0.6. Here we are, anyway it is reduction taking place, that's why we are taking as it is. Now, how to calculate the EMF? E cell is equal to E cathode minus E anode. Which is cathode? Copper is cathode. Which is anode? Zinc is anode. So that's why E cell is equal to E cathode. What is the electrode potential of cathode? 0.377 minus of 0.76, because here E cell minus, and what is the electrode potential of 0? That is anode, minus 0.6. So minus of minus 0.76. It becomes plus 0.377 plus 0.76. It comes to 1.1 volts. That is the EMF of Daniell cell. So here, while substituting, you should remember that while taking here the minus is the formula. Minus 0.76 is its value. So if already there is minus, if you just forget writing this minus, the whole thing reverses. It becomes negative. EMF. So negative EMF will not give you the that is electricity. So some problems on EMF of a cell. The standard reduction potential of magnesium and cadmium electrodes are minus 2.37 volts and minus 0.4 volts. Calculate the EMF. So among the magnesium and cadmium, as the reaction it shows, magnesium is anode and cadmium is cathode. So what is the formula? E cell is equal to E cathode minus E anode. So E cathode, what is the electrode potential of SRP of cadmium electrode? Minus 0.4. And what is the electrode potential of magnesium? Minus 2.37. So here it is taken as it is minus 0.4 minus 2.37. Is it minus of minus 2.37? It becomes minus 0.4 plus 2.37. That is 2.37 minus 0 minus 0.4. It comes to 1.97 volts. Did you follow it or not? Yes. Let us go for another problem. That is standard electrode potentials given again. The same thing. Calcium and lead are given. Calcium is minus 2.9 and lead is minus 0.12. Which one acts as anode? Obviously minus 2.9 is the least. That one that acts as anode, and minus 0.12 that is lead acts as cathode. Calculate the EMF of cell. So as I told you, calcium acts as anode, lead acts as cathode. E cell is equal to E cathode minus E anode. So what is the value of E cathode? Minus 0.12, that it is written as it is. Minus, what is the EMF of, what you electrode potential of calcium? Minus 2.9, minus of minus 2.9. So minus 0.12, minus of minus becomes plus 2.9. So minus 0.12 plus 2.9, it becomes 2.78. 2.9 minus 0.12, it becomes 2.78 volts. So even this also produces electricity. Let us go for the third problem. Here also standard electrode potential of silver and lead are given. Silver is 0.8 volts and lead is 0.12 minus 0.12 volts. Among these two, which one is having more electrode potential? Silver is having more electrode, it is plus, whereas lead is minus. So even they have given the cell notation. So silver is acting as but here the cell notation is given as Ag plus by Ag by Pb2 plus by Pb. Actually it should be in reverse. So if if the silver is anode and lead is cathode, can it give electricity? No. So the EMF of the cell is negative. It cannot generate electricity. Why it is so? Because actually if Pb is this way and Ag is this way, it produces the electricity. It becomes 0.92. But if Ag plus is taken as anode and Pb plus 2 is taken as cathode, the EMF comes in negative. The EMF of cell is negative, hence it cannot generate electricity. So that is about the EMF. Did you follow the EMF? So simply what you have to do is, that is, if you know the standard electrode potential, simply by doing the subtraction, you can find the EMF of a cell. Is it not simple? Very simple, is it not? But you have to take the correct values and apply the values correctly in the formula E cathode minus E anode. Now, here a figure is shown. What is this figure? You have seen these device many times, is it not? That is something like a car battery, a battery that is used in cars, or even in the case of in olden days, even the computers are run with, that is computer labs are run on these batteries, is it not? So can you identify this? So you know that it is a battery. So let us study about the battery. What is a battery? How it is related with electrochemistry. So you have seen the electrolytic cell and galvanic cell. But what is this battery? So if you see a lead storage battery that is used in cars, so you see like this. There are some vertical plates, they are arranged parallelly to each other. A set of vertical plates here and another set of vertical plates are here. They are divided by, they are what you call, they are separated by some insulator blocks like wood blocks or what you call thermocol blocks, and one set are negative electrodes and another set is positive electrode. Negative electrodes are positive electrodes, they are parallelly arranged to each other, and they are, that is what you call wooden or that is wooden or plastic sheets are arranged between them so as to avoid contact with them. And what is happening here, that is all negative, the negative plates are connected to a terminal, it is negative terminal, all positive plates are connected to a positive terminal, and there is something what you call a chamber in which electrolyte solution is poured. So that is, it is all packed in a protective coating. Are able to follow? So generally you see this lead storage battery. So what is actually battery? Battery is nothing but a cell. It is not as simple as galvanic cell, but it is a cell. It is neither electrolytic cell nor a galvanic cell. It is a storage cell. What does that mean, storage cell? Means it stores, it can store electrical energy. That is called as storage cell. Simply, for example, if you take the case of battery, when battery is charged, what does that mean? It has stored some electricity, it has stored up energy. Are you able to follow? So that is called as storage battery. And when you are using, it is getting discharged. What does that mean? Whatever the energy that is stored, we are using up. After some time, what happens? It gets discharged. But that means whatever the energy stored in it, that is getting that is over, that is exhausted. Are you able to follow? So that means here a storage cell, it can operate both as voltaic cell as a and electrolytic cell. That is, it is not just galvanic cell or electrolytic cell. It acts as both electrolytic cell and galvanic cell. How it is? See, a storage cell operating as voltaic cell, not here volatile cell, it is volt, it supplies electrical energy. So what does a voltaic cell or electrochemical cell or galvanic cell means? It produces electricity or it gives electricity, that is called as discharging. So whatever the electrical energy it is having, it is giving up, that is called discharging. So after discharging, what happens? You have to just throw it off. But what we are doing, we are charging it. What does that mean? Storage cell apparatus, it is acting as electrolytic cell during recharging. So when you are charging or recharging, it is acting as electrolytic cell. So when then the in electrolytic cell, what happens? The chemical energy is stored, that is electrical energy is stored in the form of chemical energy. And when you are using the storage cell, what it is doing? The stored chemical energy is converted into electrical energy. Are able to follow? So a storage cell or a battery is the device which acts as both electrolytic cell and galvanic cell. When we are using it acts as galvanic cell, that means it produces electricity. When we are charging it or recharging it, it is acting as electrolytic cell. The simple thing is your mobiles. Your mobiles, how they are working? So you are not putting any wire. There are some batteries inside it. Is it not? These batteries, are you just changing every day the batteries? No. So the battery, so when you are using the mobile, what is happening? The charge in the battery is getting discharged. That can be seen like lines in a cell, is it not? There is a, what you call, a sign is shown. How much charge is there? Let us say 10%, 20%, or 30%. If you are charged, 100% is there. What does that mean? The battery is containing the chemical energy which can give 100% electrical energy. So when you are using this mobile, what is happening? The chemical energy in the battery, that is converted into electrical energy, that helps in functioning of your mobile, is it not? So after some time it goes down from 100% to 90% to 80%. If it reaches to 20 or 10%, again you get alarmed, you'll put it for charging. What does that means? We are putting the charge with a, what you call, in a plug socket. You are putting the plug and you are supplying the electricity. So again the electricity is supplied, and again the reactions are get reversed, and the electrical energy is converted into chemical energy which is stored up there. And when you are using, that chemical energy is converted into electrical energy which is used up. So that is charging, discharging. Charging is electrolytic cell. Discharging means electrochemical cell or galvanic cell. So the common example is lead storage cell. We have to see. So in lead storage cell, you have a number of lead plates that are connected in parallel to each other, which act as anode. Similarly, a number of lead oxide plates connected in parallel, which acts as cathode. So you have lead plates, lead oxide plates, a series of lead plates, a series of lead oxide. Are lead plates and lead oxide plates are parallelly arranged to each other, alternately arranged to each other, and they are arranged in such a way that there will not be any contact between the plates. They are separated by insulators like wooden sheets or plastic sheets or rubber sheets. The lead plates fit in between the lead oxide plates, as I told you. All the plates are separated from each other by insulator like strips of wood or rubber or glass fiber. The entire, that is these both the plates which are arranged parallelly, which are separated by insulator sheets, insulator strips, all this arrangement is immersed in a common electrolyte. What is that common electrolyte? Dilute sulfuric acid, 20 to 21% of sulfuric acid. So what are the electrodes here? Lead plates acting as anode, lead oxide plates acting as cathode. So the battery consists of 6 cells connected in series. Each cell is having an EMF of 2 volts, giving 12 volts as the overall EMF of the battery. Are you able to see? In each battery there is one anode, one cathode, let us take. So such 6 batteries are arranged in a series. Each battery is producing 2 volts of electricity. Totally a battery is giving 12 volts. So a lead acid battery is giving 12 volts of electricity. So what is the electrode potential of anode? That is lead plate, 0.36 volts. So here Pb plus HSO4, that is, it is in the presence of what you call in the sulfuric acid electrolyte. It turns into PbSO4. So H2SO4 gives HSO4 plus H plus. So it is giving us PbHSO4, PbSO4 plus H plus, giving 2 electrons. Pb is turning it to Pb2 plus. PbSO4 means Pb2 plus. So what is happening here? The Pb is turning to Pb2 plus. In PbSO4, the oxidation state of Pb is Pb2 plus. So what do you call this reaction? Pb turning to PbSO4? It is oxidation. So that's why it is anode. Cathode. At cathode you have PbO2. PbO2, it reacts with HSO4 and H plus ions, taking 2 electrons supplied from the Pb plates and form PbSO4 to H4. Here in PbO2, what is oxidation state of Pb in PbO2? It is plus 4. And even it is also becoming PbSO4, but here it is becoming plus 2. So what is happening? The oxidation state is reduced to plus 4 to plus 2. Why? Because it is taking 2 electrons. So what do you call this reaction? If this is oxidation, this is reduction. This is losing electron. Those electrons are gained by this PbO2 plates. So in both the cases, on both plates, PbSO4 is formed. And H2SO4, H plus and HSO4, that is sulfuric acid, is utilized. So what happens to the concentration of sulfuric acid? So sulfuric acid is utilized and PbSO4 is formed on both Pb plate and PbO2 plate. Pb is converted to PbSO4 by oxidation. PbO2 is converted to PbSO4 in reduction. So on both anode and cathode, what is the precipitate that is formed? PbSO4. So that is, as a result of both oxidation and reduction, on both the plates PbSO4 is formed. So this is the what you call discharging reaction. What is happening? Pbs plus SO4 2 minus PbSO4 plus 2 electron. At the cathode, so here anode is negative terminal because it is acting as galvanic cell. It is getting discharge, means it is acting as galvanic cell where anode is negative. So oxidation takes place at anode. And at cathode, what is happening? Cathode is positive in galvanic cell. It is also it is undergoing reduction. The overall reaction during discharging is overall reaction, that is both at cathode and anode, are able to see PbS, that is taken at anode, plus PbO2, that is taken at cathode, 4H plus plus 2SO4 2 minus, that is 2H2SO4. You can, that is, it is written in the form of ions, 4H plus plus 2SO4. So Pb and PbO2, they are taking 2SO4, 2 PbSO4, it not just PbSO4, 2 PbSO4 plus 2H2O. This 4H plus takes away this O2, 2H2O. So that is, electrons flow from Pb to PbO2. Pb by giving electrons it form PbSO4. PbO2 by taking electrons also form PbSO4 plus 2H2O. So in this way PbSO4 is formed. It is not just PbSO4, 2 PbSO4 which is deposited on both anode and cathode along with water. So instead of sulfuric acid, what is found? Water is found. What happens to the concentration of sulfuric acid? It is reduced. But due to the flow of electrons from Pb to PbO2, what is happening? The energy is produced. What is that energy? Electrical energy. So what is happening during discharge? The Pb is undergoing oxidation, PbO2 is undergoing reduction, due to which electrons flow is there, which releases energy. Is it not? So due to the discharging, what happens? Pb and PbO2 slowly they get exhausted and it turns to PbSO4. So that is happening. Just it is a graphical representation. If it is a little bit confusing, but you just remember only these reactions separately and combinedly. So what is electrolyte? Electrolyte is sulfuric acid, which is gradually used up to form the lead sulfate. Both electrodes become coated with an insoluble layer of lead sulfate, which being an insulator would eventually ruin the battery. If you continue this reaction, that is totally the Pb as well as PbO2, they turn into lead sulfate, which forms a layer on the both the electrodes, and being insulator, it eventually ruin the battery. It will damage the battery. So during the manufacturing, the electrodes are filled with the lithiates and immersed in electrolyte. When an electric current is passed through the battery, the electrode that labeled negative is converted to lead, while the electrode that is labeled positive is converted to PbO2. There is no net change in the concentration. The process is called as forming the battery. So how the battery is prepared, that here they have given. The electrical status of the battery is indicated by the concentration of sulfuric acid, indicated by its specific gravity, Sg. So as the concept, that is what you call the charging in the battery is shown on your mobile screen. Here also, the status or electrical status of the battery, whether it is in the discharge condition or charge condition, it is given by specific gravity of sulfuric acid. The electricity of a fully charged battery has the electrolyte of a fully charged battery has an specific gravity of 1.30. If it is discharged, it comes down to 1.10. That is the battery getting discharged. If the battery is totally discharged, both electrodes will have to be converted to lead sulfate, will have been converted to lead sulfate. That means it is no longer able to provide current and cannot be recharged. So that is, it is good for scrap. So you should see that it should not go totally discharged. The Sg will be slightly above 1, indicate most of the sulfuric will have been used up. So what is happening during charging? So the first reaction, PbO plus 2 electron H plus PbS plus H2O. PbS plus H2O gives weight. Okay. So here they have shown that is PbO and PbO. PbO is turning into Pb, PbO turning into PbO2. That is during charge. After charge, you will get Pb and PbO2. When the battery is charged using a battery charger or motor charge, an electrolytic process takes. So when the battery is going to discharge completely, what you have to do? You have to charge it again. It can be charged by using a battery charger, or even a motor car contains an alternator by petrol. It can be charged. An electrolytic process that takes place, that is, electrons are supplied to the electrode that is labeled as negative, cathode, as it accepts electron. In as a galvanic cell, the cathode is positive, cathode is positive and anode is negative. But the negative becomes cathode here in electron, and this converts the lead sulfate to lead. At the same time, the lead sulfate is the positive electrode. Earlier it was cathode, now it is anode. It gives up electrons and it's converted to lead dioxide. So discharging, just you see. So here Pb is turned into PbSO4, PbO2 is turned into PbSO4, partially discharged. What is happening? Fully discharged, PbSO, PbS. There is no, that is H2SO4 concentration is totally zero. It is almost, so here partially. So only at this stage you should charge it. So again, these are the charge, that is discharging reactions here given. So again, completely discharged. Pb turn to PbSO4, PbO2 turn to PbSO4. On charging, again you will get PbSO4 to Pb, PbSO4. So that is, it is completely charged. Is it not? So that is, when you do the charging, you will get, again you will get the Pb and PbO2. So that means if you want to make the battery run, you should have Pb and PbO2, not the PbS or PbS. If it is completely PbS or PbS4, then it is totally discharged. These are the charging. That is PbSO4 giving rise to Pb, PbS4 giving rise to PbO2. And here, sorry, in the previous case, what is happening? Energy is produced. See, energy is produced. Here the energy is utilized. You are selling the energy from from external source. PbSO4, that is, here by utilizing the energy, these reactions are occurring. There the energy is produced, here the energy is utilized from the external source. So care must be taken to distinguish which electrode is anode and cathode, as this will depend on whether the battery is charging or discharging. During discharging, negative electrode is anode, positive electrode is cathode, because it is galvanic cell. But during charging, negative electrode is cathode and positive electrode is anode. Are you able to follow? When discharging, the cathode will be the site of reduction, anode will be the site of oxidation. So that about so that is about the EMF and lead storage battery. So an electrochemical consists of two electrodes. The difference between the electrode potentials of two of cells is called as electromotive force. So E cell is equal to E cathode minus E anode. We have done some problems regarding the EMF of the cell depends upon the nature of the reactants, concentration of the solution in two of cells. Are able to follow? And reactions of lead acid battery. The overall reaction in during discharge, Pb and PbO2 turning to Pb and PbO2 using sulfuric acid turning to PbSO4 giving rise to H2O plus liberating electrical energy. That is, here during discharge, that is Pb and PbO2. Pb is undergoing oxidation, PbO2 is undergoing reduction using sulfuric acid. PbSO4 is formed on both the plate with water. So what happens when sulfuric acid is turning to water? The concentration of sulfuric acid decreases and energy is produced during discharge. It is acting as galvanic cell, so energy is produced. The overall reaction during charging, just you can write the reverse of this, not even two reactions. Sorry. PbSO4, 2 PbSO4 plus 2H2O gives rise to Pb plus PbO2 plus 4H plus 2SO4. Is it not? Two electrons cancel. So here, to undergo charging, you have to supply electrical energy. Here the electrical energy is produced during discharging. So you need electrical energy during charging. That you should remember. So that is about the topics of today's session. Shall we go to the quiz? In a cell containing zinc electrode and normal hydrogen electrode, the zinc electrode acts as anode, cathode, either anode or cathode or none of the above. So in presence of hydrogen, hydrogen's electrode potential is 0 and zinc electrode potential is minus 0.76. Definitely when it is connected to the hydrogen electrode, it acts as an anode, because it is having less than, that is electrode potential less than that of hydrogen. So the right answer is anode. A series of cells arranged in a row, is it called a battery or voltmeter or accumulator or chip? So it is simply a battery. Anode in lead storage cell or battery, it is called as PB. What is anode, PB or PbO2? So you know that all these things are present in lead storage battery. Which is anode? PbSO4 is the product that is found on both the electrode. H2SO4 is the electrolyte. The last two options are wrong. So among A and B, A is anode and B is cathode. So the right answer is A. Cathode in lead storage cell, obviously B. Both anode and cathode get converted into Pb, PbO2. They are anode and cathode. They are converted into H2SO4 is a electrolyte. So the right option is C, PbSO4. On both anode and cathode, a layer of PbSO4 or lead sulfate is formed. Sulfuric acid concentration during charging. Does it increase or decrease or remains constant? So during charging, what happens? The concentration of sulfuric acid increases. So those are the things, frequently asked questions. So it is something similar to galvanic cell. So just you will be given a cell reaction and you are asked to, this is a problem, 0.763 volts is the oxidation state of what you call a standard electrode potential of zinc, and cadmium electrode potential is also given. Just you are asked to find out the EMF. So what will be the one? 0.403 minus of minus oxidation potential is given. So minus 0.403 minus of minus 0.763, it comes around roughly I think 0.30, I think. Right, the reaction that takes place during charging or discharge. So this is En in lead acid cell. You have to write both sets. So that is as a galvanic cell, as a electrolytic cell. The reactions you have to write. What are the indications of fully charged cell? Its specific gravity should be 1.3. What are the indications of fully discharged cell? It reaches to 1.1. Calculate the EMF of cells constructed in previous assignment using electrochemical series table given in text. Prepare the chart of lead acid battery showing reactions during charging and discharging. That's all for today. Shall we stop? Okay. So I'll meet in the next session with the new topic. Okay.